this has become both a professional trip and a personal trip, and I've been enjoying it a lot. So, but that's not what I came to talk about today. I want to talk about the normalizing machine, and the normalizing machine is an art installation that some of you, I believe, already got the chance to explore. That was an attempt for me to and my partners to address what is exactly the problem with how machines are looking at us, and I'll take it. I'll start with talking about a bit the history of how we look at people in comparison to other people, how we create systems of indexing and categorization, and then what happened with. I'll take you through that history that is slightly also echoed in the installation itself. So, like everything, it has to be has to happen in 3 acts. So I'll start with the criminalization of the face, the history of that. Talk a bit about algorithmic normalization and what exactly do I mean by normalization. And then I would try to argue for Simple AI. So 3 titles that mean nothing to you, but then I'll try to make sense of them. So I'll start with criminalizing the face. So I want to take you back to Paris of the late 1800s. You have to understand that this is the Industrial Revolution. Paris is a big city, and unlike the history of society at large, all of a sudden you're surrounded with people that you've never seen before. Like, think about it. We lived in villages or small cities, where more or less you live your life around people that you've seen in the past, or somebody knows who they are. But all of a sudden, during the mass urbanization of the Industrial Revolution, you get more and more people coming into the city, and nobody knows who they are. Nobody, including the police, that when the police arrests people, and these people are saying that the name is whatever, they have no way of knowing if they are who they are. And the police is starting to use photography. These are the early days of photography, and they're using photography to try to understand, like, who are these people. And as you can see, they're photographing them in many different ways, but they have no way of knowing if this person is who he says he is. Let's say he says his name is Philippe Tréjoli or whatever. But they have no way of knowing that he is in fact the notorious terrorist Ravakol. Not until this person enters the scene. This is Alphonse Bertillon. Alphonse Bertillon was a police officer in the Paris station. He was also the son of a statistician, and he's considered of the mugshot. And you all know this composition. This has become the image of criminality. But what's in the core of this composition is the first time the photographing of portraits is being standardized. So to create a portrait that is meant to identify a person, Bertillon said, this is how you take the portrait, like one from the front and one from the profile. And you enter it into a file, into a card, and you write some additional data points. And this card that you might have also seen in the installation itself has become the way you need to arrest people. When in the process of the arrest, you need to create this card. And it's not only a matter of photography, you also need to take additional measurements. So he developed a whole system that was called after him, the Bertillonage, in which he would measure different aspects of the body and add that into the index and into the logging of who this person is. This person has this picture, like this is the front, this is the profile, the arm is that length, the ears are that size, and so on. All of that is becoming data, right? Data that he not only archived, but also aggregated. And he created what he called les portraits parlés. He tried to have, like, the problem was that if the person wouldn't say their name, their portrait would talk for them, right? So the portrait parlé, the speaking portrait, and he collected different pictures that they had of mugshots, and then he said, if this person, and it was an indexing system, right? So he looked for different types of noses, different types of mouths, different types of eyes, different types of ears, many different types of ears. He was really into ears. He was like kind of sinking into the ear in a way. Like for him, it was like amazing. Oh, so many types of ears, and then for him, every one of these things was an archetype for an index. Because the only thing he was interested in is to say, okay, we just arrested you. Have you been here before? You're saying you haven't been here before. Let me check that. You have this ear, you have this nose. Let's see if we have you in our database archive of photography. And if we will find you, we know you, right? It's not a pile of pictures that there's no way of managing anymore, because he created an indexing system. And for him, indeed, it was an indexing system. And this has become a hit, like a big hit in police work. It was studied. It was like the way you do it, and not only in Paris, all over the world, it would become like the standard for how you arrest someone. You want to arrest someone, you take their pictures and you start measuring them. And it spread all around the Western world. Every police station that knew what it was doing that for about 8 years until this happened. A slightly more convenient, quick, and accurate system, the fingerprint. But the mugshot remained, and it's with us until today. And while the whole cumbersome system of the Bertillonage has been phased out of police work, there were other people that were interested in it. A big fan of Bertillon's system was Francis Galton. Francis Galton was Darwin's half-cousin. He read the theory of natural selection as a prescription for society. So rather than an analysis, he was looking at natural selection. He was saying, okay, so this is not like how things happen. This is how things should happen. Like we should make we should support evolution. We should push it forward. And he coined the term eugenics, and advocated for responsible breeding. Like in that sense, natural selection, nature needs some help. We need to make sure that we're responsible in the way we recreate. And his theory really evolved this idea of like eugenics societies. So, for example, they had this nice little thing called the Better Baby Contest. You would bring your baby, and you would try, and they would check how perfect your baby is. Obviously, even beforehand, they would make sure that you are perfect enough to mate with another perfect person to create perfect babies, because we're all in it to create perfect babies, people. So this basically strain of scientific racism was creating the basis for social Darwinism, like a racist interpretation of survival of the fittest. And when they encountered cases like this, even the case of a slit lip, that we all know that is not a big deal, that is a big no-no, because that is a sign that there has been irresponsible mating, and this is a defect that we need to make sure that doesn't continue into evolution. And they really created forced sterilization laws and so on. And you have to understand this in the beginning of the previous century. This was a big thing, not like all over the Western world, like especially in the U.S. The Americans were really into eugenics, and they created laws that would prevent people, like what's called forced sterilization laws, prevent people from making babies because they might be passing defects into that existing in their heritage. Not very surprisingly, these guys were into that as well. You probably can read it better than I do, but the translation that I got is this person suffering from hereditary defects cost the community 60,000 Reichsmarks during his lifetime. Fellow German, this is your money too. So all of these, this irresponsible recreation is something that is straining society, and we need to be responsible about how we deal with that as a society. We all know where that went. Now, when we get back to Bertillon never meant for that to go there. And when he was asked about it, he was saying, I do not feel convinced that it is the lack of symmetry in the visage, or the size of the orbit, or the shape of the jaw, which makes a man an evildoer. He was basically, he said, I've seen many different types of people that look very, very differently, and they were criminals. He used it as an indexing system. He was just trying to create identification, not categorization. He wasn't trying to say, you look like a criminal. He was just trying to make sure that you are who you say you are. But his system was used differently. So let's talk about algorithmic normalization. We continue to another figure, important figure in history, Alan Turing. So Alan Turing, you might have heard the name before, you might have seen the movie before, The Imitation Game. But in World War II, Alan Turing was one of the main scientists who cracked the Enigma, the Nazi Enigma machine that was used to encrypt messages and to the U-boats. He was indeed one of the Enigma code breakers. In 1944, they managed to crack the Enigma code. They managed to understand what the Germans were communicating. And some say that the work that they did in Bletchley Park in the UK might have shortened the war in 2 years, which means millions of lives on all sides. And after the war, all of this was still undercover. Like nobody knew about the Enigma, nobody knew about the team in Bletchley Park, and Turing, who basically created the basis for computing, and he's considered the person who invented computer science, and he started to be very interested in the idea of machine intelligence.
And in 1950 he published a prophetic essay. I propose to consider the question, can machines think? This should begin with definitions of the meaning of the terms machine and think. The definitions might be framed so as to reflect as far as possible the normal use of the words, but this attitude is dangerous.
So he understood that you can embed thinking into machines and into computer processes, and he started to think, like, what does it even mean for intelligence? And he realized that in extrapolation of the work that he's been doing, and we're talking about the really, really early days of computing, the extrapolation of that is a machine that thinks. And he devised this idea, which was he called the imitation game. It was later called the Turing Test. And until today, the Turing Test is considered the gold standard for AI. The idea is text-only communication. You have one person in a room, and that person is chatting with two entities. One of them is a human, one of them is a machine, and that person needs to guess which one of them is the person, which one of them is the machine. If the machine manages to fool the human enough times, then it means that it passed the Turing test. So from just a note about that, from the early days of artificial intelligence, it was about fooling humans. It's like that is like the way you say, oh, this is good. This is making people understand something that is not true. Okay. Another thing about Alan Turing was openly homosexual. In the early 50s, that was something that you're not supposed to be in the UK. And in 1952, he was convicted of homosexuality, and he was given two options: either go to jail or be chemically castrated. This is a hero of World War II, but nobody knows that. Definitely not the whoever gave him that option. And he chooses the chemical option, and he becomes very depressed and sick. And in 1954, he ate a cyanide-laced apple. I'll put it at that. There's like many theories. Did he take his own life? Was he murdered? I won't get into that. What I would get into is some of his writing about AI, because he was really interested in a concept that he called the child machine. He was saying, instead of trying to produce a program to simulate adult's mind, why not rather try to produce one which simulates a child? It will not be possible to apply exactly the same teaching process to the machine as to a normal child, of course, because it wouldn't be a normal child. So, he was afraid that the AI child would be victimized for its otherness. He was imagining that machine child going to play with other humans and being made fun of and victimized because that machine is not like them. Fast forward to today, in 2017, Stanford researchers trained a neural network AI system to identify gay faces. And when they released the results, and as you can see, like 91% accuracy with the detection of gay men, 83% with gay women. There are different critiques of that study, but when they released it, they were saying we're really disturbed by our findings. Just half a century earlier, the gay researcher was concerned about the otherness of the machine. It kind of flipped on its head in a way that the machine has become a system. For him, he was thinking of that machine as this being the actual neutral and objective human, not like the humans who victimized him. That would be a rational machine. That child machine, the artificial intelligence would be logical, would be rational, but the way we're using artificial intelligence now is not to create something that is detached from the biases of culture, but rather what we're getting is an amplification of these biases. The study also concludes that homosexual men and women tend to have gender atypical faces, morphology, expression, and grooming styles. And now something from my home country, Israel.
A startup company based in Tel Aviv says it has developed software that can identify terrorists and other criminals based on their facial features. Faception's learning algorithm program uses 15 classifiers and genetics to uncover an individual's personality traits.
We see many signals in the face which are coded from the DNA, and this is a way we can make analysis or personalization of anyone.
Of anyone. It's in the DNA. Just look at the face. The machine would tell if you're a criminal. And now the way machine looks at humans is separated to face detection, like we detect a face in an image. Face recognition, we recognize that face, we know that this face belongs to that person. And then face analysis, we can say something about that face even if we don't have that in the data, because we have a model and we know when we see that face, we know what to think of it. And this bias that we're talking about, we can say that there's nothing new there, because when humans are looking at humans, first of all, they say, okay, I see a face. I recognize that face. And we also apply our own systems and our own patterns and our own biases to say, this is a normal face, right? Or this is an abnormal face. But I would argue that the main difference is this. We have eyes. Right? Each one of you have eyes that are not only looking at somebody else, they are being looked at. There is a certain, when we're talking about the kind of relationships that Bertillon was creating this system for, it was between humans. Like even in this picture, and we can imagine a whole story behind this picture. This is someone who definitely did not want to be a picture of him taken, right? But there is someone there, and he's holding his face, he's capturing his picture quite literally. But that person, that police officer is there. There is still a human relationship between someone who's looking and somebody who's being looked at. Both of them have this kind of basic human balance that is definitely being positioned in contrast because of this, because of the power structure of the situation, but it's still between two humans, and the power dynamics is very, very clear, as we can see in this picture. But what we're getting with these kind of eyes is something that is very different. It's not the same way of looking. It's not the same way of relationship between the eye and the person being looked at. And in a way, this systemic bias has evolved. It has been depoliticized because the political relationship, the power dynamics are hidden. The eye is always looking, and we don't know what this image does later. Act 3, Simple AI. If you are not like everybody else, then you are abnormal. If you are abnormal, then you are sick. Michel Foucault talks about these 3 categories: not being like everybody else, not being normal, and being sick are in fact very different, but have been reduced to the same thing. Like there's this line between, that is really the line of how we manage normality, right? How this idea of normality is baked into this systemic bias. And we've started to see more of these systems being used very, very widely. Now there are crime predicting algorithms that would even be used for when a judge needs to decide whether to give someone parole. There are startups that would offer them more information. They're not telling the judge what to do. They're just offering more information. These type of people tend to create to commit more crimes. So we might want to think twice before doing that. Again, under the guise of being scientific, objective, and so on. This is the backdrop for the normalizing machine. And we wanted to start with the question of how does a normal person look like? To teach the machine, and again, there's this framing that is kind of naive in a way, like many of these artificial intelligence startups. We're going to teach a machine how does a normal person look like, and for that we kind of build a Turing test of sort. The way it works is represented with 2 portraits, and you're asked to point at the one that looks more normal. We have 5 rounds of that, and at the 5th round, you're compared. Your own image is compared against the image of the person you selected as the most normal. And then the image of that of the participant is being fed into the system that in this version of the installation was in the screen on the right, and then broken into different cards, like we've seen before. And these cards are being analyzed and entered into a table based on the portrait parlé, and creating scales of normality, right? So these scales are the scales of eyes, scales of ears, scales of noses, and so on and so forth. So in a way, we're saying, yeah. I'll keep it visual. I really like this quote from Canilem. The abnormal, while logically second, is existentially first. logically there's normal, and after the normal there's abnormal. But the way we experience normality is we don't see normal people. We see when something is abnormal. And that's what jumps in front of our eyes. So when we ask people to point at the normal of the two, they're trying to check which one of them looks less normal. And then by pointing at the normal, which is kind of, again, depoliticized, kind of normal, it's normal to point at normal, you are also pointing at the abnormal. Okay? And technically, that's what you're doing. So we want to thank many participants in this experiment. This is just like a small selection from an exhibition in Berlin. But I'm mainly when I'm talking with people next to the installation, every now and then there will be someone who I would be asking, so you want to try it out? And that person would say, I get it, no thanks. So it's this one, right? So I think this is probably the best response that this installation can receive. We don't really want to be a part of the system, and the work is trying to be seductive. It's kind of echoing some of our selfie instincts that we definitely want to see our pictures. We kind of want to be analyzed, but then we don't. But even those who say, I don't want to be a part of it, can you really not be a part of it? When you're, when every system that you use online is constantly gathering data and trying to create an image of normality. Like a like is pointing at someone who's normal in a way, right? And when you're clicking a like on something, you're also not clicking on other things, right? We're constantly creating these categorizations, and in the background we're constantly creating scales, right? Definitely with photography, but even every gesture, when you're swiping something, every element of your interaction is being analyzed, it is being compared and being normalized. So how does it work? We have a system, we have subjects, and this is like what was happening before the World War II, right? We get subjects. These subjects are captured by the police, by the camera. They're being datified, like turned into data, measured and turned into numbers, and then being put in an archive, in a data set, somewhere where they can be compared with others. And that creates affordances like identification, which was exactly what Bertillon was interested in. As far as Bertillon was involved, that's where it was supposed to end. But it didn't end there, because it continued into categorization. It's not only this person is that person, it's more like this is good, this is bad. This is normal, this is abnormal. This is sick, this is criminal, and so on. And all of that is fed into a model of how do we look at people from now on? Like, how do we create systems to create the perfect babies? How does a perfect baby supposed to look like, okay, right? And you can get an analysis, a eugenic certificate that you indeed can marry. That is a recommendation of the system. These kind of recommendations and can feed back into the system, making the system more perfect. And finally, that leads to action. Now, that action can be sterilization laws. It can be other types of actions. And when we look at the systems that we have today, we'll see that they work exactly the same way. We get subjects. They're being captured. They're being datified, entered into data sets, and then identification. Who doesn't like their phone to be opened magically when you're just looking at it? That is as naive as Bertillon's system, right? But that doesn't end there. It continues into categorization, normal, abnormal, models, analysis. This is the Chinese social score. And then, based on this analysis, again, feeding into the system, and then action. And that action can be in the level of you don't get to get a parole, but it can be even much less dramatic. It can be what's called affect recognition. We can now identify your expressions, and more companies and education systems or public housing are using face recognition to decide on job interviews, for example. Like, this person is like, we've seen some micro expressions in his face. It doesn't fit the profile of the kind of person that we want in our company. Does it, like, and there's bias on every step of the way, right? Every step of the way we can think how bias creeps in. It's definitely not objective, right? But the bias, especially as close as you get into action, into the areas where power is exercised and actually put into action, it's not a technological bias. It's a societal, political bias. And we cannot separate the two. That's why Kate Crawford wrote in Science in the last summer, these tools are dangerous when they fail and harmful when they work. It's not about mistakes. We really like to make jokes of robots that are falling down the stairs and stuff like that. Oh, they're not perfect. We can see that. They failed. The joke is on them. No. The problem is that even when they do exactly what they need to do, the problem is how they depoliticize our understanding of them, the underlying unjust system that they serve. That's the problem. So we need to kind of move from debiasing, the idea of can we extract the bias from the machines, into a framework of justice. Like, how does it fit in a wider societal and political framework of how do we want to deal in society in general? How do we want to deal with people? The technology is just something that is hiding the decisions that we've been making there. And I'll finish with a positive tone, because it's important to finish with positive tones. The EU, we've been joking about the GDPR. Everybody's been getting too many emails that say something GDPR and then like click here to approve last year. The GDPR has become a very, very powerful tool to curb these kind of processes. And I wouldn't get too much into what does the GDPR actually mean. But we can see San Francisco bans facial recognition technology. That just happened a couple of months ago, and 2 other cities followed. And in the US, there's a bill banning facial recognition in public housing. The government is starting to step in, and we can see societies like in Hong Kong, the people demonstrating in Hong Kong really understand what does it mean to have all of these cameras everywhere, and they're pointing at them with laser tags, and they spray them, and they understand that they do not want to be looked at like that. So to conclude, AI may be useful, and it's useful in many, many aspects of our lives, but it's not seamless. It is simful. It's full of seams, and it's still, and we should still look at these seams and understand that what happens in these seams is actually us. It's our politics, our relationships, our power structures. We have not created seamless, perfect machines that would do our messy and complicated job of living with each other, which is a good thing. So thank you.